Hardware-wise, you would definitely need to have a E3D V6 hot end. In this case, this is a clone that, of course, must be configured for direct drive, so it should not have a Bowden adapter. If it does, then that is the wrong one, and you have to purchase one which does not have the adapter. Instead has this small hole for you to directly feed the filament into. In addition, you also need a stepper, and this stepper can be simply taken from the original Bowden extruder setup, but in this case I'm trying out my luck with a Pancake stepper, which I hope will reduce the weight of the carriage and hence allow me to print at a faster speed. For the main mount, you will need to get an M3x20 screw. This one goes into the hole right here and acts as the pivot for the tensioner. This one is definitely salvageable from the original mount, the original hot end extruder mount. And you also, of course, need this original tensioning, what should I call it, tensioning spring setup, and together with the spring, of course. These are all included with the original setup. You also need to get two M3x5 screws, which I do believe also came with the set, although my memory might be wrong. You also will need two M3 nuts. These M3 nuts, these ones are definitely not included, or perhaps they were, I just can't remember. And of course, you will need two M3x30 screws. The best option would be if you could get them in a countersunk configuration, because this will allow the screws to sit nice and flush with the mount. Now, speaking of the mounts, there are two parts. Mainly, this is the main mount, and this is the extruder stepper holder. So this both parts should be printed preferably in PETG, because this would allow for best longevity and best durability. The infill wise is between 50 to 75%. However, for these prints I would use 75%, and I think these have been working well so far. Some other accessories that can be added to this mount include the accessories that were originally designed for the E3D modular mount for CR10, as can be found on Thingiverse, and these include this part cooling fan mount, which requires an additional two nuts, one for this and one to mount it to the main mount, as well as another M320 screw and another M315 or M313 or anything in between screw, which can be used, or which is used to mount attach this mount to the main mount in that case. And in my case, I'm also using a BL Touch clone, which is the 3D Touch, and this also requires an M3 13 to 15 screw and another M3 nuts. Another additional feature, if you would so choose to install, would be this filament runout detector, which is comprised of this limit switch, which can be purchased pretty inexpensively, as well as additional part, which is this filament runout sensor holder or cover, which also is printed from PETG and should also follow the same settings. Since most limit switches don't come pre-installed with wires, you're going to have to solder it on yourself. In this case, I tinned 22 AWG wires and soldered them on to the two opposite terminals of this limit switch. The order in which you solder it on does not matter, as they are technically reversible. Now I'll spend some time to talk about the setup of the filament runout sensor, which is rather simple, as we take this filament runout sensor cover and we simply place this limit switch into the holes, aligning it up perfectly. And in this case, there should be only one way that it lines up, this way. If you try it the other way around, it would not be able to fit properly, at least. Or perhaps it does, but anyways, if we want to be sure, then make sure that this little bump is facing the part with the switch. So this pretty much sits in immediately, and you can just press it down to make sure that it stays put. And the wires can just be pulled out of the way in either direction, doesn't really matter. Now, to double check that everything's working, we can take our second part, which is the stepper motor mount, and we can place the filament extruder cover, filament runout sensor cover over the top as so. and we need to make sure that the metal part of the screw, I mean not screw, what am I talking? The metal part of the limit switch is facing the side which has this blank area, basically not the edge, the main edge, this side. Or we also can check that when we take a look through the point of view of the extruder or the hot end, we can see that there is a clear path for the filament to come down. So how this works will be demonstrated right now, because for instance, I have this roll of filament with me, and when you push the filament through the filament sensor, it activates the switch on its way down. Because it presses it in, the switch basically just activated. It passes through our system, which will be demonstrated on later, and it passes down to our hot end. So this is basically the system. When the filament runs out, the switch springs back up, and we have triggered our filament runout. The first thing we have to do is to place these two nuts into the nut traps. So the nut traps are here, and you have to place these two M3 nuts into them, like so. Now, when using a light hammer, we're gonna lightly tap them in. Well, depending on the type of M3 nut you have, this could be either really easy or really difficult process. And so in the original Fusion 360 files, I've added a parameter which allows you to change the size or the diameter of these nut traps so that they end up being able to fit your nut. So in this case, we've gotten it in, and what we do is we take a M3 screw. This is not part of the original set. I mean, you could, but it wouldn't be worth it sacrificing an actual screw. So in this case, I just found a random M3 screw lying around, and what I'll do is I'll just screw it in and use it to push the nut further into the nut trap. Now, I'll continue to push it in until it reaches this this region where I can start to see it, and then I'll stop. Now that's done because that's reached the maximum. And for the other side, oops. For the left side, we must be a bit careful, as on the right side, the maximum is already reached way before, like you start to see, you can see it from here. Or, oh wait. Oops, I'm silly. On the right side, there isn't the nut trap for this nut doesn't coincide with the nut trap for the other part. So hence there's no need to worry about it for the right side. However, the left side, as you can see, we can see the screw coming in from the left nut trap, and then we need to make sure that the nut does not pass into the region. This is because we will need to use the left nut trap to hold another nut for attaching the mount. So we just need to make sure that this nut does not get into the zone. That's pretty easy. If it gets too much, then we can simply screw in from the other side, use our sacrificial screw that we procured earlier, and simply just a few taps to get it back, into position. So that's done. Alright, we can take our sacrificial screw and put it aside, and now we've got a pretty decent, we've been off to a pretty good start. Now the next part would be to put in the nuts for the nut traps for our accessories. This is also the reason why we made sure that this nut doesn't get too far in. So that's pretty simple. We simply slide it in. The nut traps are designed to be kind of overly big, because then again, standardization, really not really sure if these nuts are the same size as those you can find elsewhere. However, even if they aren't, I think they should all be able to fit into these, because these are really big. So once that's done, what we can do is we can use we can try to make sure that we are able to slide the nut through the hole on each side and into the nuts in the nut trap. This is also can be done using, once again, our sacrificial screw, which requires a bit of maneuvering because the nuts are so free, which is one of the limitations to the design in a sense. As you can see, we've checked that the right side is able to be screwed in. Now we'll remove it and we'll check the left side also, and we can see the left side also is able to be screwed in. In actual fact, the nut traps really don't hold the nut in place, so later on I'll show you how exactly the nut traps need to be held in place. The nuts need to be held in place in the nut trap as we attach the mounts. So in this case, we are pretty much done with the assembly of the main mount. Now I've come to our printer and bring all my parts with me, and we are going to set up this mount. So the first important thing to note is that we have to remove the old mount, which I cannot, for reasons that I've been using this for some time, show you how to do so, because I've already removed this away a long time back. So I am not too sure how the process is, but I think it should be pretty straightforward. Eventually you should be greeted with this plate, and then that should be all that you need to do from there. So now since we're at it, I would like to point out that it'll be a good idea right now to adjust and to basically to ensure and to tighten this carriage to ensure that it's as tight as it can, because when more things start piling up, for instance the stepper motor, the 3D printed parts, the extruder for example, this carriage is going to get pretty heavy, and that can really affect the overall balance and also like the rigidity of this mount or this carriage, and how resistant it will be to shaking. So I feel that it'll be a good time now to just double check and to make sure that this is as tight as possible. And how that can be done is, for instance, if we were to look here, if it could even possible for me to slide the camera. Can be seen here, there is a little like golden colored piece of sort of like a nut that this golden colored nut that essentially will control how high and how low the bottom wheel on this, or the bottom roller on this carriage is, and that will essentially impact how loose or how tight it is. So the only way to tighten this is to take an Allen key, or to take a wrench, or to take a plier and basically rotate these until we find the sweet spot which we feel is comfortable and which feel that this is at its least shaky. So I'm just going to do it right now.
Much later.
Now that we have tightened up everything, now let's install the mount. So the mount slides over like this, similar to the original mount. And let's go ahead and take our two M3x5 screws that we took just now, and let's just screw them in. Alright, so these two screws hold the mount to the mounting plate. So it is paramount that they are as tight as possible to prevent any unnecessary shaking or wobbling during print. You can test how tight they are by just simply trying to shake this, and if you see it, this is pretty solid. Alright, next, instead of mounting the extruder on, first we will instead mount the side extensions first. So the first thing that we'll mount is most likely to be the part cooling fan, which will mount on this side like so. So in this case, what I'll do is I'll take the M3 by 13 to 15 screw which I mentioned earlier, and I'll simply place it inside here like this. Oh, before that we should put in the nut. This nut is an M3 nut, and that goes in as per the instructions in the original HCR10 modular mount. Now we just slide it in and let the nut trap that we did earlier catch it. So the way that this mounts is that if you're fast enough, you could technically catch the nut and bring it in, but if not, you could use one hand to put in a screwdriver of some sorts to hold the nut in place while you screw it in. But I find the moment you're able to catch it, you can use the inertia of the nut to just quickly spin the screw, and that should pull the nut in. Now for the next one, I will be using a BL Touch or BL Touch clone, which is the 3D Touch, and this one goes to the side like this, and this of course is all part of the original mount designed for the E3D on the CR10. These are all available in Thingiverse, and hence I will not be going to do much detail about them as they're not really part of my work. So once again, we slide the screw in, and this time, because the nut is pretty low, it's pretty not really very close to where we need it to be, we would take a screwdriver and we would attempt to bring it up. And this is kind of silly. I mean, it is not a very clever way of doing things, but as for now, I've not been too worried about that.
Much later.
In my case, you've got the nut in, it just won't come out. Well, I use a magnet in this case to get it out. But if somehow you put it in and it just refuses to come back out, I'm afraid the only way left is to simply just take the entire setup that's so fine, take it out and and knock it out with gravity.
The next day.
Oh, finally managed to get it in using attaching a magnet to the screwdriver like this, and then using it to hold the screw up. But that really took too long. I think the future improvement would definitely be trying to make this nut trap a bit more intuitive. However, it seems that we did it. So what we have to do now is we just slowly loosen the individual sides to ensure that we can still move the individual attachments. This is because we don't really know the exact height of the hot end yet, and because we're going to be attaching the hot end now. So make sure it's not too loose such that the whole nut trap, like the whole nut slides out, because that basically brings stuff back to square one, but just loose enough so that you can still move it around. So in this case, I'll loosen this a bit so I can like slowly slide it up. So it's pretty good. Now we're going to install the main part of our system, which is the extruder. So the extruder is I've already wired it out, everything's wired, so the extruder fan is up. And what we do is that for most of these clones, there'll be a part where this extruder kind of like sticks out from the back, as you can see, and that part will be facing in. An extruder fan will be able to clear the heater block and be able to stay here without having any issues. So what we do is that we simply put the hot end into the mount like this, and then we take our other part, which is the one that we just printed, also this piece. Of course, if you have opted to go for the filament runout sensor, then that will just be sticking out like this, and you mount it. So the groove should line up pretty well. There should be a little bit of tension between, a little bit of squeeze between the inside, the outer and the mount and this cover, but shouldn't be too much. For instance, like once it's attached, you see that the extruder should be fairly firm. So In this case, this looks pretty good. Now I'll go ahead and take my two M330 screws, and I will just attach them to these holes here. And this is why you need the screws to be of countersunk configuration, because if not, they won't be able to line up well with the frame or with the 3D printed part. They'll most likely not be able to they will probably protrude out, and that will get in the way of the extruder, the stepper motor. Want to tighten these screws to probably be as tight as possible. You can see that this whole thing looks pretty solid. There's minimal shaking. Shaking probably comes because of there's a little bit of slack in the carriage, which we tried to fix just now, but there's still a little bit, but it should not be too much. And then again, this really won't matter because the shaking is in the Y direction, and this extruder moves, this whole carriage moves in the X direction, so that should be too much of a big deal. Now we take our stepper motor. So this is the original stepper that came with the CR10. This was the original extruder stepper. It's pretty chunky and it's pretty heavy, so we might opt for a smaller one, which in this case is Pancake's stepper motor, which way light. I think it's about half as heavy. What am I saying? Anyways, this might not have the torque. We're not sure about that, but it does fit really nicely because it's NEMA 17. Everything should work for this as well. The only downside might be that perhaps one of the screw might not be perhaps the depth of this might not be enough to fit the entire screw, but we'll see. So what I will do is that for the sake of this video, I will probably try using this this Pancake stepper. So any updates whether or not it really worked will be in the description, perhaps after the video. Alright, so what I'll do is I'll take this Allen key and remove this tooth gear of the initial stepper motor. So it would be pretty simple, just removing it. I should bring the camera down. Everything should be able to be salvaged from the original printers. So now we just mount it about the same place about the same location. So it should be right at the end of this stepper. We can always check and change it if necessary. So, and on these steppers, you will see that for the shaft there is a little groove, which is a bit of a flat region, and that's where you need to put one of the grub screws must bite in one of their regions, and the other one will bite at the other side, which is here. So that's definitely I think looks good. Now, so if I bring over here where we have top view of the assembly, well, what we do is that now we will fit the stepper motor into the hole, which is here, and yeah, this looks pretty good. Perhaps the tooth gear, yep, this position seems about right. And now what we need is we'll use the screws that we have to attach this stepper motor in place. So what we'll use is take the the spring, and then we'll put it into a little spring holder over here for the spring. And then we'll take the original idler, place it this way. Oh, sorry, I forgot to mention before that, you will also need an M3x10 screw. This screw will mainly be, it is needed to hold the stepper in place because the stepper needs to be held by 4 screws, but in this case we only use 2. So this just screws in here. Anyways, forgot to mention it at the start, but I'll put a link, or I'll put a bill of materials or whatever you need for this build in the description, so that way you can just double check and everything should tally. Then we take our spring, we place it in the spring groove over here, and then we take this idler belt, we place it here, and then we'll stick the M3x20 screw that we mentioned earlier, and we also screw everything in. So it's kind of hard to see in the video, and I can understand. So perhaps if there's any questions or any issues in setting this up, maybe you could email me or so. Happy to hear from you. Alright, so the final product should look something like this. Oh boy, why can't I do anything? Something like this. So it should look something like this, where there is screws holding in the stepper motor, and also everything should be tight and secure. There will be more information in the blog post as well, because currently it's pretty hard to do the filming and do the movement at the same time, so sorry about that. Alright, so that now that we've got everything, at least for the stepper wise, everything is more or less hooked up. Let's just double check with a piece of filament to see that everything is tied in. So I'll take this roll of PETG filament. See, it just fits in here. Oops, this is a bit thick. And I just need to double check that everything can slide into the extruder. So in this case, we have to chop the first part, which is a bit expanded off. I should be able to push it right into the extruder. Oh no. Should take this off for a while to just double check. Yep, and I think that's all the way in because it's not heated, so I can't really tell if it's jammed anywhere. You'll see when we heat the filament up, heat the hot end up to see that really works. So this thing's a little bit flimsy, this holder, because it's not really screwed in, it's just a mere clip-on design. I'm not so sure how to change that, perhaps I will. But for now, since for the sake of being able to remove it quickly for troubleshooting, I think I'll just leave it as so, perhaps with a little rubber band around it to just double check. But I think so far everything looks pretty good. Alright, so now that we have everything set up, it's time to do our final touches. In this case, we will be installing our part cooling fan, and we'll be basically trying to level the bit and check everything works. So our M3 20 screw, and we can simply just slide it into the part cooling fan, this little mount, screw mount, where we can mount it to our little mount here. It pretty much seems to have set in. Alright, so that's done. Hook it up. Last but not least, we need to then level everything to make sure that the heights are correct. So in this case, I'll just check that my part cooling fan isn't too Isn't too high, too low. In this case, it seems about right. Yeah, moving out a little bit. It seems about right. Now I'll just tighten it using the screws, using the screw at the side I mentioned earlier. Alright. As for the auto bit leveling sensor, this is a bit of hit and miss. So the best way to do it is probably to go to auto home. Oops. And then we will simply just adjust it so that somewhere around where we think it's level. This is a wee bit too high. Now probably trim it up a bit. Be here. Yep, this is pretty good. I'll just tighten it. Right, so now let's just check again. Overall, this has been a very interesting experience for me as there has yet to exist a true blue direct drive extruder for the CR10 that is 3D printable. Most other designs so far that I've seen still feature a form of Bowden tube between the extruder and the hot end. I've yet to try printing flex on this hot end, partially because I don't have a need for a flex part, and also flex is rather expensive, but perhaps in the future I'll give it a shot. And also since the extruder is literally just above the hot end, I don't think this should be too much of an issue. As mentioned, I will be editing the design to make the nut traps for the side extensions more intuitive, as well as perhaps devising a better way to have the filament mount sensors stay in place. The only other major issue that I found so far was that my stepper motor was kind of overheating, as can be seen, and I think that was more of an issue with the stepper driver than with a mechanical fault. Overall, I'm quite satisfied with this design thus far, definitely a very worthwhile project. Until then, I'll see you next time.